to Baozi Training and Leetcode solution. I hope you guys are doing well. Enjoy the coming Thanksgiving, and also Christmas, the holiday seasons. I hope everybody will have a great time. Today we're going to talk about this problem, candy. So what is candy? So there are n children standing in a line. Each child is assigned a rating value. Essentially, well, I'll skip all this. So essentially giving you an array with all the integers. Each integer represents the rating of one child. And then your rule is each child must have at least one candy. Well, in Halloween, you don't want kids to have no candies, right? So they need to have at least one. And then children with higher rating get more candies than their neighbors. So for example, their neighbor means both ways, right? Their left neighbor and also their right neighbor. So if 0 has one candy, that means 1 has to have at least 2 candies. And then 2 also has to have at least 2 candies because both of them have higher ratings than 0, so they need to have more candies than 0. So the minimal amount is 5. So the question is, what is the minimal candies you need to give? Note that if, for example, your children, you only have 2 children, they have the same score, then it's okay, they just have 2 candies. You have to have higher rating in order to receive higher candies. So by a first quick look at this problem, I think we should all be able to come up with a very naive solution. So think about this. When you go over the array, you just need to make sure, okay, am I actually, assuming I have 1 candy at my current position, do I have more candies than my left neighbor? If I have higher ratings than my left neighbor, so I increase my candy value. If I have higher values than my right neighbor, I increase my candies. So let's use one example to illustrate this way. So let's say your current ratings are 5, 3, 1. So essentially, let's say, okay, I'm position 1, I have 1 candy, so the rest of you guys have 0 candies. So now I'm at 3. How many candies do I have? So like I said, you cannot have no candy, so you have to have at least 1 candy. And then you look to your left neighbor, you're like, okay, you're 5, so you actually have more ratings than me, so you need to have 1 more candy than me, so you increase the value by 1, so now you have 2 candies. Now you continue, okay, you're at position 1, the last child, you have 1 candy, because you cannot have 0 candies, right? You give it to 1, and then you check the left neighbor, there's no right neighbor, you check the left neighbor, and it's 3 is higher than you, so you increase the candy by 2. So now you think, oh, okay, in total, I only need 5 candies. However, that is actually not accurate, because whenever you do this, it's a cascading effect. You will affect all your neighbors because you are comparing both left and right. When you increase your left neighbor in this case is you increase to 2. You have to consider, well, your left neighbor might also have higher ratings, so you have to increase all the way down to the essentially index 0. So in this way, if you increase this value to be 2, you have to keep increasing, checking the value. Oh, am I? And 5 and 3, who has higher rating? Oh, 5 has higher rating, so that means 5 should have more candies than 3. So you have to increase this by 3. So that will increase your total to be 6. So as I just illustrated, right? So this is O(n) squared solution, because you have to, every time you have to kind of like check if it has higher ratings on the left part. You have to check all the way because of the cascading effect. So if we put that down into code, so this is a naive solution. So first we do some sanity check. If everything is 0 or none is 0, or else if that's only 1 is 1 candy. And now here's the thing. So you start from index 1, assuming the first child has 1 candy. You do the comparison. So if I'm actually having less candy than my previous one, that means I need to give myself, first of all, 1 candy, but then that means I need to increase my left part candy by 1 because they have higher ratings than me, my previous one, right? So note, it's not just a direct neighbor using my example, right? So you have to go all the way, yj larger than 0, all the way to the left. If the rating is actually higher, then you increase the ratings by 1. It's a cascading effect. Or else, this case is you actually have larger ratings, so you just pretty much put your left neighbor and then just do it by 1, increase it by 1, or else you have less ratings, right? So you just basically default to 1, and then at the end count everything to 0. Okay, so this is the naive case, is O(n) squared, definitely not ideal. So what should we do? Here the hint is sometimes when we think about, oh, it's O(n) squared, can we optimize it? So should we try to solve it in O(n) or log n? In this case, log n is not even possible because you have to visit each node. So how can we solve it in O(n)? Think about, instead of doing 1 pass, can we do it in 2 pass? The clever idea is do it in 2 paths. So first from left to right to ensure all the left neighbors constraints are satisfied, and second pass ensure all the right neighbors constraints are satisfied. More specifically, I listed here. It's a little bit kind of like a tongue twister, but if you're going from left to right, ensure I have more points than my left neighbor if my ranking is higher, else I just got 1 candy. And then you're going through this path, you ensure all your left, essentially you will have more candies than your left neighbor if your ranking is higher, or else you just default to 1, right? You only have 1 candy. You have to at least have 1 candy minimum. And then this is you satisfy 1 part, and then you go in from right to left. Ensure I will have less points than my right neighbor if my ranking is higher, else need to increase the right neighbor's points. I think I should put it more like this way. So first you give left to right, you ensure you have more points than your left neighbor. And then going from right to left, so you're ensuring you have more points than your right neighbor. So in that case, it's like you have, in that case, you have more points than your both left neighbor and right neighbor if your rankings are high. Ensure I have less points than my right neighbor if my ranking is higher. Sorry, I think I write it wrong. It should be ensure I have more points than my right neighbor if my ranking is higher. So I'll change that later. But essentially, let's still use the same example to explain, right? So first I want to go from left to right. I want to ensure I have more points than my left neighbor. So 1, so default to 1, and 3. So if you're higher, you have more points, right? So if you're not higher, you're just 1, right? And 1 compared to 3, if you're higher, you will have more points than your left neighbor. But if you're not higher, you're just doing 1. Now this is left to right. Then we do, this is L to R. And then we can do right to left. So here from right to left, so you start with 1, and then you check the values. Okay, 3 actually has more values than 1, right? So you basically increase to 2. Has more rankings. And then 5 and 3, so this would be 3. So in total, this would be 6. Another way to think about this, like I said, left to right, ensure you have more points than your left, and then right to left, ensure you have more points than your right. And also, whenever you're changing the value, you're always changing the value going forward in one direction. You never go back and change value, right? When you go from left to right, you always basically change the value on the right part. You want to ensure the right part is correct. Now, when you're going from right to left, you're always changing the value. You never go back, change. For example, if you compare 3 and 1, you will never change the value of 1. You change the value of 3, ensure the right part, because you already satisfied the left part given the previous thing, right? Previous path. So that's the whole idea. That said, the code looks like this. Same thing, validation. And then this is from left to right path, like I explained. You're only updating the right part of the value because you're going from left to right. And then you're going from right to left. See here, you're only updating the left part of the value because you're going through this direction, like from right to left direction, and then you sum them together. Time complexity O(n) for this method, and the actual space complexity is O(n) because of the candies array you're using. All right, leave any comments if you have any questions. I'll see you guys next time. Bye.